Hey guys, thanks for tuning in. Now that we've already looked at a lot of vector-based quantities like force, acceleration, velocity, momentum, another great way to analyze a lot of physical scenarios is to understand them based on their energies. Okay? Now, there are many different types of energy in this world. Okay? That there's energy, there's light energy that comes from the sun, there's heat energy, there's chemical energy stored in sugars and other types of bonds. And in a macroscopic perspective where, cars and buses and trucks and everything is moving around the road, we can take these big type of energies and classify them into a gravitational potential energy and a kinetic energy. Gravitational potential energy is energy that is due to position, okay? And more specifically, position in the y-axis, how high an object is. Because GPE, which is your gravitational potential energy, is equal to mass times gravity times height, mgh. Okay? When you multiply these three values out, you get a value in joules. Kinetic energy is energy due to speed. Okay? The equation for kinetic energy is 1/2 mv squared. Again, we get an answer in joules. Okay? So all of energy is measured in joules. And so this tells us that energy can convert back and forth easily from gravitational potential energy to kinetic. Let's do a simple example. Take a marker or a pen and throw it into the air. Okay? The moment that marker leaves your hand, you've given it kinetic energy. That kinetic energy, as it travels to higher heights, loses kinetic energy and gains gravitational potential energy until it reaches the very top, where it momentarily stops for a second, and it is all gravitational potential energy before it starts to come back down and transfer back to kinetic energy. Okay? So that's just a simple experiment that you can do to kind of see the changes in energy. And what you should do is that whenever you're doing a problem that requires you to analyze a situation based on energy, is to write up a quick energy chart. Okay? So in this case, I have a 10 kilogram object elevated to a height of 100 meters. So the energy chart looks like this. We are going to classify how much GPE we have, how much kinetic energy we have, and then add them up, and that will total what we call the total mechanical energy, which is the GPE plus the KE. Okay. So in this problem, the mass is 10, the height is 100, and gravity is 10. So it gives me 100 times 100, which is 10,000. And so I have 10,000 joules of gravitational potential energy. Well, my box is at the maximum height. It's not moving, so kinetic energy is going to be 0. And so when I add GPE plus KE, I get 10,000 joules. Now this is the total amount of energy in this system. This energy will remain in the system unless we talk about non-conservational forces like friction and air resistance. But in many problems, we're going to learn to neglect those two forces and therefore keep the amount of energy in the system the same. So therefore, it's saying that if I have 10,000 joules of total mechanical energy at the beginning, then I should also have 10,000 joules of total mechanical energy as the box hits the ground. Okay? So let's do another energy chart, which is GPE, KE, and total mechanical energy. Well, because we know that the total mechanical energy has to remain constant, I'll just carry that value down, and that becomes 10,000 joules. And now since we're at the ground, my gravitational potential energy is equal to 0 joules, and therefore all of the GPE at the very beginning of this problem must have converted to kinetic energy, which is going to be in the amount of 10,000 joules. And now that you know that there are 10,000 joules of kinetic energy, you can solve for something else like velocity. So I can go ahead and say kinetic energy is equal to 10,000 joules, and kinetic energy is equal to 1/2 mv squared. Set that equal to 10,000, and now I can go ahead and solve. So it becomes v squared is equal to 2,000. Therefore my velocity is going to be equal to about 40-ish, 43. Now, as you would see, is that you would get the same result if you were to do this problem using kinematics and using the initial velocity to be 0 here and the acceleration to be 10 meters per second squared, and as this object falls we can calculate the final velocity. And you'll see that using energy or using kinematics will yield the same result, but oftentimes it's easier to use energy. Let the problem dictate which way you want to go, but practice both techniques because they will both be very useful on exams and quizzes. Thanks for tuning in. Stay tuned for the next video, okay? It's Neel signing off. Bye.